Washington Mills was founded in 1868. It is the oldest existing producer of abrasive grain in the United States. Its New England founders insisted on uncompromising standards of quality, reliability, and service to its customers. Today, it is one of the largest producers of fused minerals and abrasive grain in the world. With multiple facilities throughout North America and Europe, Washington Mills has the unparalleled ability to serve customers worldwide. Washington Mills combines old-fashioned integrity with over 100 years of industry experience. The business of Washington Mills is the conversion of raw, naturally variable minerals from all over the world into electrically fused synthetic minerals with uniform qualities. From macrogrits to microgrits to custom specialty fusions, our fused materials are engineered to perform a multitude of tasks across a wide variety of industries and applications. Our products are used in grinding wheels, sandpaper, kiln furniture, pressure blasting, heat-resistant shielding, wire sewing, ceramic parts, thermal sprays, metal finishing, and much, much more. Washington Mills products are an integral part in thousands of applications. In our multiple furnace and processing plants, Washington Mills starts with specially selected raw minerals such as bauxite, alumina, and other minerals, depending on the product that is to be made. The minerals are weighed and mixed together before they're fed into the furnace. A furnace technician controls how the mix is delivered to our numerous arc furnaces. The minerals are fed into the furnace through movable chutes, which evenly feed all areas within the furnace. In the seething 3,800-degree Fahrenheit bath of molten alumina, the electrodes charge the minerals with an intense electrical current. The minerals melt and fuse together. Natural impurities found in the raw materials are reduced to controlled amounts. Molten alumina is much hotter than molten steel. By comparison, it's 1,100 degrees hotter than the lava in a live volcano. Periodic dip samples are taken, quickly chilled, and rushed for laboratory analysis. When the desired chemical analysis is achieved, the furnace supervisor signals for a pour to commence. After pouring several tons of molten alumina, the liquid is allowed to cool. The molten material continues to cool, and the chemistry and crystallography of the material is checked. The mold is transported into a cooling bay, where it stays for 24 hours until the ingot has fully solidified. The mold is then hoisted by a crane and transported to the breaking floor, where the ingot is dumped and broken into head-sized pieces. The materials are then transported through conveyors to different crushing systems, where they are progressively crushed into smaller-sized pieces. High-intensity magnets are used to remove any excess iron from the material before it receives further crushing. The crushing process at Washington Mills is controlled by computers. Operators adjust the crushing process through a computer system according to the size of the grit that is to be made. A flexible array of advanced crushing, handling, and sieving systems allow us to produce grains with a range of characteristics to suit the varying demands of many industries. Screens are assembled in decreasing mesh sizes to make a kind of shaking sieve. The screens sift the particles through the screens with the largest mesh first, then down to the smaller ones to sort them by size. For some perspective, we'll place a quarter against the various mesh sizes. As you can see, only the finest particles of grit would pass through the tightest weave. Billions of closely sized particles stream through Washington Mill's high-capacity sieving machines daily. Our sieving systems produce uniformly sized products to meet customers' specifications. The grits fall through tubes and into hoppers, a different one for each grit size. The grits are sieved to precise sizes and shapes for a wide variety of applications. Maintaining consistent high quality is a #1 priority at Washington Mills. Our laboratory service group offers a complete research and testing facility. In our lab, samples are carefully analyzed for physical properties such as sieving, bulk density, particle size distribution, and magnetic content. Using advanced laboratory capabilities, Washington Mills maintains exacting control over the chemical composition, the purity, and the crystal structure of the material. We use the most current methods of analysis and tools, including X-ray diffraction analysis and X-ray fluorescent analysis. In a fast-changing world, Washington Mills believes it will serve its customers' interests best by steadily improving its products, developing new products, and by responding quickly to its customers' needs. In short, we are still committed to the principles we established over a century ago.